today I will explain you about linear transformation. Linear transformation is an important topic of linear algebra. So, linear transformation. So, a map, first we define definition. A map T from V1 to V2, where V1 and V2 are two vector space. Map is called linear transformation if first condition T of x plus y is equal to Tx plus Ty for every x and y belongs to V1. We know if x and y belongs to V1, then Tx and Ty belongs to V2. And this operation plus is operation for V2. And this plus is operation for V1. Actually it is same, but sometimes it will differ based on vector space. And second, condition T of alpha x is equal to alpha Tx for every x belongs to V and alpha belongs to field. Alpha is a scalar. So, if T satisfies these two properties, then it is called linear map or linear transformation. Or combinedly we can say T of alpha x plus beta y is what? Alpha Tx plus beta Ty. X and y belongs to V1 and alpha beta belongs to field. So either you show these two properties separately or a single property, this one. Then T is called linear map or linear transformation. Example. T from R square to R square defined by T of xy is equal to yx. First and second, T of xy is equal to x1 square y. Well, T of xy is equal to x plus y, comma x minus y, and both x comma y minus y. So, after seeing these four examples, we can say easily first and third are linear map, but second and fourth are not, because here is square term is there. So definitely it will be not. But how we can prove this is linear and this is not? So I will do it. First one. So what is the procedure? Procedure is very simple. Take any two element of V1 and alpha and beta in field. So here V1 is what? R square. So take any two element of R square. So let x1 y1 and x2 y2 are two elements of R square and alpha beta belongs to field. So now find out LHS value and RHS value. And so both are equal. How we do? T of alpha x LHS. T of alpha x means x1 y1 first element plus beta of second element. What is the value? T of alpha x1 plus beta x2 comma alpha y1 plus beta y2. Quantum wise addition and multiplication, scalar multiplication. Now T of first element and second element, T of xy. What is the image given? T of xy is equal to y comma x, means it is equal to alpha y1 plus beta y2 comma alpha x1 plus beta x2. Now what is RHS? RHS is alpha T of x1 y1 plus beta T of x2 y2, second element. Now we calculate the value alpha. What is the value of this? y1 comma x1. What is the value of this? y2 comma x2. So what is the image? Alpha y1 plus beta y2 comma alpha x1 plus beta x2. See, LHS is equal to RHS. Both are same. It means T is linear. Similarly, we can put for anything. For third question, second, why T is not linear? So, what is the image of this? Up to this step, same. We have taken two elements. We complete this one. Now, this one only change. What is the value? LHS value? Its image is x1 square comma y, means it is equal to alpha x1 plus beta x2 square comma y, means alpha y1 plus beta y2. This is the final value. And what is RHS value? Alpha of T of x1 y1. What is the value? x1 square comma y1 plus beta of x2 square comma y2. What is the final value? Alpha x1 square plus beta x2 square comma alpha y1 plus beta y2. So see, y component equal but x component not equal. It means LHS is not equal to RHS. It means T is not linear. So this one. So in this way we can tell when T is linear and when T is not linear. This is the way. Now I will tell you some properties of linear transformation. Let T from V1 to V2 be a linear transformation. Then what are the properties below? T of E1 is equal to E2. Identity corresponds, means identity of V1. What is the image of identity of V1? E2. Identity of V2. So because both are vector space, T is mapped, so identity will go to identity only. So V1 identity we have taken E1 and V2 identity we have taken E2. So identity correspond. And second, T of A inverse is equal to TA whole inverse. Both properties are very important. You can prove it easily if you want. Now I will tell you about kernel T and image T. We will do some questions based on this property. So kernel T and image T, but later. So kernel T and image T means let T from be a linear transformation. defined as x belongs to V1 such that T of x is equal to identity. Means those elements of V1, here E2 identity is there, those elements of V1 whose image is what? Identity of V2. This is very important in so many ways. I will explain later. But how we calculate kernel? Always map is defined to you. Take that map Tx is equal to identity, whatever identity is there for V2, and then solve it and get the values of x, y, z, whatever order is there. That is your kernel. And what is image of T? V belongs to V2. There exists or y belongs to V2, x belongs to V1 such that T of x is equal to y. Means image means those elements of y V2 whose pre-image exists, that belongs to image of T. No. First, kernel of T is a subspace of V1. Why? V1 because it contains elements of V1 only. Kernel is what? Those elements of V1 whose image is identity. So elements of V1 only it contains, so that's why kernel is a subspace of V1. Second, image of T is a subspace of V2 only because it contains elements of V2. Third, dimension of kernel T is known as nullity of T and denoted by nullity. Fourth, dimension of image T is known as rank T and denoted by this is very important properties. Fifth, if T is a linear transformation from V1 to V2, then this is very important. Rank T plus null T is equal to dimension of V1. This is known as rank nullity theorem. This is very important. So, if T is a linear transformation from V1 to V2, then rank T plus null T is equal to dimension of V1. These five properties play a very important role in linear transformation. So, I will how we calculate kernel. There are so many ways, but how we calculate kernel T, I will tell. Let's take one example. T of from R square to R square such that T of R cube to R cube xyz is equal to xy0. Then kernel T. How we calculate kernel T? Those element of R cube. So xyz belongs to R cube such that T of x means xyz is equal to 0 of this. 0 of V2. R cube 0 is 0, 0, 0. Now solve it. T of xyz, what is the value? xy0. It means x0, y0. So for z, no conditions given. Z may be any value. It means x and y must be 0, but z is having value. What is that? That is z axis. What is kernel of T? Z axis. T from second example, R square to R square. T of xy is equal to x plus y, x minus y. So what is kernel T? xy belongs to R square such that T of xy is equal to 0, 0. So T of xy 0, 0 means this is x plus y comma x minus y is equal to 0, 0. It means x plus y 0 and x minus y is equal to 0. So what is the value? x0, y0. What is kernel T? 0, 0. Only 0 elements. One important thing. What is the dimension of kernel T if it contains 0, 0? Only this element is there. 0. Why? Why 0? It contains 0, 0 na? So why it is 0? Because dimension means number of element in a basis, and here it contains 0, 0. So 0, 0 cannot form basis because any set which contains 0 element is a linearly dependent set, not independent, and basis must be independent. So that's why it is not formed basis. So basis contains only 0 element. Dimension of kernel is 0. And what is the dimension in this case? Think it and do it. So in that way we calculate kernel T. Once you know kernel T, then easily you can go for, suppose for this, what is the rank T? Rank of T is what? Use rank nullity theorem. So rank T, dimension of kernel T is 0. What is dimension of V? 1, 2. So rank T also. Corresponding to every linear transformation, there exists a matrix, and if you find that matrix and when you calculate its rank is true only. So whatever quotient is there in matrix, it means we can convert in linear transformation also. If they ask anything for linear transformation, you find out corresponding matrix and calculate that one, either rank or kernel T, also known as nullity, null space. You know how we calculate null space, row space, column space. So that's all. So this is about linear transformation basic. In next class I will explain about invertible linear transformation, and we go for so many things. Means vector space homomorphism. What? This is also known as vector space homomorphism only. So set of all vectors homomorphism forms a vector space again, that is home VW, and algebra of linear transformation we will do, and definitely we go for isomorphism, because invertible, once you know, we go for isomorphism. Okay, so thank you, and hope you all understand this one.